We built it. We stuck it on a rocket, it made it to space, it opened up robotically, and it's been giving us views from the first hundreds of millions of years after the Big Bang.
So if you think about it, since the beginning of time, every fairy tale, every myth, every story the humans have been telling or yearning to learn about is the story of origin.
We've come from somewhere. There's some process that has led us here, and it has implications for where we're going to go. And so we're going further and further into the past over time. Now we can see galaxies and we can observe them and we can actually analyze them. And that frontier has been pushed forward exclusively by Webb.
My research kind of was spurred by a surprise, really inspired by a very early result of JWST. There was this time period where we were like, we are finding galaxies that are so massive.
So it's kind of like, you go look for baby pictures of your kids and you find, they're like 8 feet tall. You're like, what the heck? What's going on?
As more data comes in and we revise our understanding, Webb hasn't changed anything in terms of our understanding of cosmology in the very base level. Our Saramalic cosmology still holds.
One of the things that's been the most exciting so far has been the discovery of a lot of massive black holes and galaxies in the early universe. And it's exciting because we weren't quite expecting that.
We see a lot of objects that contain black holes. In some cases, these may be bigger than we thought, or can you make black holes that move so fast? Also, how can you make a black hole that is so much more so massive compared to the galaxy?
There's just a higher abundance of very massive black holes in the early universe.
And so one thing that happened with this Webb data is this flurry of scientists working on galaxies and scientists working on black holes is kind of coming together to try to understand what exactly we're seeing.
We found a bunch of objects that are incredibly difficult to explain, that there's a lot of controversy over, these like little red dots.
We call them little red dots. Those are very creative. They look exactly like little red dots in the images. They're so compact, but there's so much light coming from them. In the early universe, there's only so much time to build up exorbitant amounts of our mass. How is that physics happening?
We are made of things like carbon, nitrogen, oxygen, and other elements, but the Big Bang made none of them. So you want to find the stars that made the elements that ultimately made us. So it's part of completing the picture.
It is a sea change. It is a sea change. There's no question. JWST has offered a complete change to the way that we think about the first billion years of the universe.
There's a sense of wonder that astronomy inspires, regardless of whether or not you are a scientist. And James Webb, I think, has had a huge part in bringing that sense of awe to everybody. This is just the beginning, and Webb is just